Hello and good morning. Today we're going to begin by recalling what a prime number is. So what a prime number is basically a number that's only divisible by 1 and itself. Let's begin by looking at some numbers and deciding if they're prime or if they're not prime. Here we have 3, and we have to decide if 3 is a prime number. Now 3, every number divides itself, so we can say that the divisors of 3, so here I'm going to write divisors. Well, we can always say that we can always say that the number divides itself. So 3 goes into 3, and we can always say that 1 divides any real number. So here 1 fits into 3 evenly. Now the goal is to see if there are more possible divisors other than these two. If there are more divisors, then the number is not prime. If this is it, then this is prime. And we can see here that we can't find any other whole numbers that fit evenly into 3. So here we're going to conclude that 3 is prime. We're going to do a similar process for 15. So let's list the divisors here. And again, every real number divides itself, so we can say that 15 goes into 15, and then 1 divides any real number evenly. So the goal is to see if we can find more numbers that fit perfectly inside of 15. And here I noticed that 5 can go inside of 15 perfectly 3 times. I can also see that 3 fits into 15. 3 divides 15 5 times. So you can see that here we were able to find more divisors other than these two. Hence, we're able to conclude that 15 is not prime. Let's take a look at 2 now. And let's begin by listing the obvious divisors. So let's write divisors. And the obvious ones are itself and 1. Now if we can find more numbers that fit inside of 2 perfectly, we will say that 2 is not prime. However, we see that that's not going to be the case. 2 and 1 are the only whole numbers that fit inside of 2 perfectly. So here we're going to say that 2 is prime. 2 is only divisible by itself and 1. Let's practice how to get the prime factorization of any number now. And I'm going to get the prime factorization by doing a factorization tree. So the first step is to find 2 numbers that multiply to 70. And here I know that 10 times 7 will give me a total of 70. And now I'm going to take a look at each number here, beginning with the 10 here. So the 10, I have to decide if I'm able to keep on decomposing it. If I cannot, then it means that the number is prime. So here 10, I can actually find another combination, multiplication combination. Here I can say that 5 times 2 is 10. Okay, let's see if we can do the same for the 7. So 7, we can see that the only possibility would be 7 times 1, meaning that 7 is only divisible by itself and 1. So I'm going to mark it, I'm going to circle it, emphasizing that this number is prime. Now we take a look at the 2 numbers here and see if we can break them down a bit further. But we can already see that 5, the only possibility is 5 multiplied by 1, meaning that 5 is also prime, and then 2 would also be prime. Hence, the prime factorization of 70 will equal 2 times 5 times 7. And when we write the prime factorization, we always multiply the numbers from least to greatest. Let's do one more. Now let's get the prime factorization of 28. I have to find two numbers that multiply, and we get an answer of 28. So here, I know that 4 times 7 would give me 28. You could have also done 14 times 2. The prime factors are going to be the same at the end. So as long as you get a correct multiplication, you should be good. Let's begin on the left here with 4 and see if we can keep on decomposing it. So here we can see that 4, we can break it down as 2 times 2. If we look at the 7, we've already established that 7 is prime. So here, we're going to circle 7. And then likewise, on the bottom, we've already established that 2 is prime. Since we don't have anything else, we can conclude that the prime factorization of 28 is going to equal the product of 2 times 2 times 7. Again, listing the values from least to greatest.